I'm just trying to get my camera set up because this is a very high-tech operation. Hopefully that will last. Okay. So standard form of a quadratic function or equation is written like this. And sometimes you'll see it as y equals, okay? F of x, this is pronounced f of x, or the function at x. That's the same thing as the y value of the function, okay? So you need to know the axis of symmetry. So the axis of symmetry has a formula, and it has to do with this form of the function. So the formula for the axis of symmetry, and I'm just going to abbreviate it as AOS instead of writing out the whole thing. The formula is negative b divided by 2 times a. So negative b just means the opposite sign of b. So whatever your b term is, you take the opposite sign of it and divide it by 2 times whatever your a term is, okay? And the reason you want to find the axis of symmetry is so that we can help graph it and so that we can find the vertex. So let's pause a second and say, okay, here's my two-dimensional graph, right? Here's x, here's y. A quadratic function, when you graph it, takes the form of a parabola. And a parabola is a symmetrical shape that looks like a U or an upside down U, and it's the same on both sides. So let's just say this is my parabola, okay? Let's erase it and make it a little bit off-center so that it's clearly off-center. And let's see, so here's my x. I'm just going to extend my x a little, and here's my y. So let's say our parabola looks like this, okay? They go down and out forever. This isn't a perfect one. It should be like going out and down and out and down, okay? This is a quadratic function that opens down. So in this case, the vertex is going to be the highest or lowest point of the quadratic function. And the axis of symmetry is the imaginary line that cuts the function into 2 equal pieces, okay? So this shape is symmetrical across this line. So for every point over here, there's an equal point that is equally distant on this side. So this cuts it in half. It's so anything that's symmetrical has an axis of symmetry. So if you look at the human body, right? Like I'm symmetrical, not perfectly symmetrical, but symmetrical, right? I have one arm over here, I have another arm over here, I have one eye here, another eye here, my nostrils, right? My legs. So you have an axis of symmetry through a human body also, right? So the axis of symmetry of a person would cut right down through the middle. Most people have 2 arms. Most people have 2 legs, right? So this is where you're symmetrical. So it's the same idea for a parabola. And the formula for finding that axis of symmetry is negative b divided by 2 times a. So that's going to give us the x coordinate of this axis of symmetry. So this one, let's just pretend this is -1, -2, -3, -4, -5. So in this case, our axis of symmetry would be at x equals -3. It just has one coordinate. It doesn't have a y value. It just has the x value. So in this case, our axis of symmetry is at x equals -3. The reason why we want to find that out is because eventually we're going to use this formula to find the vertex. So the vertex is the same x value as the axis of symmetry, but it's going to be a different y value. So what ultimately we can do is we can take x equals -3 and put that into every x in our quadratic function, and then we can find the y value, which will be the y value of our vertex. So we'll have the coordinate of our vertex, x, y. The x is going to be -3. The y is going to be whatever the function ends up being when you put in -3 for x. So that's just the intro, and then I'll do another one with a specific example.